Question 5. We're given that y is root 3 times cos x plus sin x. We want to express this in the form r sine x plus alpha. The first thing to do is look at the r sine x plus alpha. Put down r, open a bracket, and sine x plus alpha expands out as sine x cos alpha plus cos x sine alpha. Here we're using the identity for sine of a plus b. Expanding the bracket, this gives us r cos alpha times sine x and r sine alpha times cos x. If we now compare this line with the original equation, we can see that r cos alpha is the coefficient of sine x. Here 1 is the coefficient of sine x. It follows that r cos alpha must be equal to 1. R sine alpha is the coefficient of cos x here, and root 3 is the coefficient here. It follows that r sine alpha must be equal to root 3. We need to find r and alpha. One approach we can use is to square equation 1 and add it to equation 2 squared. Squaring the left-hand side of 1 gives r squared cos squared alpha. Let's add that to the square of the left of number 2, which is r squared sine squared alpha. That's going to be equal to the right-hand sides squared and added. We have a common factor of r squared. If we take it out, we get cos squared alpha plus sine squared alpha is equal to 1 plus 3, which is 4. Cos squared alpha plus sine squared alpha we know is 1, so r squared is 4, and then r must be equal to 2, since we're told that r is positive. Now to find alpha, we can do equation 2 divided by equation 1. For the left-hand sides, we get r sine alpha divided by r cos alpha. And for the right-hand sides, this will be root 3 divided by 1. The r's cancel here, and sine alpha over cos alpha is tan alpha. So we have tan alpha is root 3. Knowing our exact values, we know that alpha is 60 degrees. And since we're asked for the answer in radians, that means that alpha is pi by 3 radians. Bringing those values back to here, we know that r is 2 and alpha is pi by 3 radians. Therefore y is equal to 2 times the sine of x plus pi by 3. In part B, we're told to find the values of x such that y equals 1. This means that we need to solve the equation 2 sine x plus pi by 3 is equal to 1, and we need to do this between 0 and 2 pi. Dividing both sides by 2 gives sine x plus pi by 3 is equal to a half. since we probably feel more comfortable using degrees, let's solve this as sine x plus 60 degrees equals a half. The principal value is going to be the inverse sine of a half, which is 30 degrees. If we draw a cast diagram, 30 degrees is in the A quadrant, and for a positive sine, the other angle will be in the S quadrant, and symmetry means 30 degrees from the horizontal axis. We need to pick out solutions in the range from 0 to 360, which is equivalent to 0 to 2 pi in radians. X plus 60 then is going to be 30, and then 30 before 180, which is 150. Continuing on, we meet no more solutions. Subtracting 60 from both sides gives minus 30, and 150 take 60 is 90. But minus 30 is not in the correct range. So let's go forward and pick up one more solution. 390, which is 360 plus 30. When we remove 60 from this, we get 330, which is in the correct range. So we have two solutions between 0 and 360. So summarizing, we have that x is 90 or 330. But we need to give the answer in radians. 360 degrees is the same as 2 pi radians. So 180 is the same as pi radians. To convert from degrees into radians, we need to multiply by pi over 180. If we do this to 90, 90 goes into here once and here twice, giving us pi by 2 radians. For 330, 30 goes into here 11 times and into 180 6 times, giving us 11 pi by 6.